Hello, thank you all for joining me today. My name is John Tkachevsky. I'm the president and co-founder of FileCatalyst. Today we'll be talking about FileCatalyst Direct. It is December. I apologize for my slide. It says November here. It should be saying December. Oh my gosh, we're already in December, and there's still not a trace of snow here in our snowy Canadian winter. So, anyways, welcome all, and let's get started. As I mentioned, my name is John. We do have a blog on our website at filecatalyst.com/blog. There's lots of interesting articles on that page to on the blog site to give you information about file transfer, security, safety, and then you have a lot of webinars. All the webinars I do, which is probably pretty much one a month, they are all recorded and you can watch them through on our website if you go to the webinar section. So today I'll give you a quick corporate overview. We have lots to cover, so I'm going to try to go through it quickly, but not so quickly that I'm going to lose you. So we're going to go through a corporate overview. I'm going to tell you why FileCatalyst is faster than TCP and introduce you to a FileCatalyst protocol. I'm going to give you a demo of our FileCatalyst Direct product, and then I'll talk about some considerations if you're thinking of implementing an accelerated file transfer solution down the road. If you have any questions during my presentation, please enter it in the GoToMeeting webinar, and I will get to your questions at the end of my presentation. Also, if you hear some kind of technical problems, do not hesitate to enter that as well in the questions. The last thing I want to do is people not hear what I'm saying. Um, so yeah. So what we do? Well, here at FileCatalyst, we concentrate on data transfer. So if you want to move a lot of data in bulk using the internet or even using a private IP link, that's our specialty. We've patented our own protocol that is based on UDP, that is immune to latency and packet loss, which I will touch on in a minute. And we'll try to make all your file transfers as simple as possible to just make your business easier. A lot of businesses these days, not only high-tech companies, but media and entertainment, genomics, surveillance and security, um, uh, as well as backup and services solutions. They all those businesses require a lot of data to be pushed, and this is our goal here in this company, is to make this data transfer for businesses simple. We also one of the other facets we do is that we provide data delivery tools for cloud services such as Amazon S3, OpenStack, Windows Azure Blob Storage, and so on. And finally, we give you all the management tools. So when you're transferring files, you know what was transferred and when and how fast. And if there's a problem, you can identify what happened. This webinar is really on direct, so I'm not going to be touching much on monitoring and management here. It's going to be more just about the data transfer, but we have these tools available as well. So let's go back. We're going to go back here to 1970 and talk about TCP. So TCP is really the backbone of the internet. Everything everything on the internet today is based on TCP. TCP was invented back in, I think, early 70s. Based on TCP protocols, some other very common protocols were invented as well, such as FTP. Um, these things have been around for quite some time. TCP is ideal for browsing web pages, sending emails. It's good for getting getting notifications on your phone that something arrived. But it's never really been designed to move bulk data. So once again, keep in mind that TCP is there. It's the backbone of the internet, but it's not designed really for bulk data transfer. So what's the main issue? Why is TCP not good for bulk data transfer? Well, there's TCP when it sends, in essence, when TCP sends data here, you can see my little diagram. When the source creates basically a packet of data, this packet of data has to be sent to the destination, and then the receiver has to acknowledge this one packet of data before the sender generates the next packet of data and sends it. So what this creates is that this is called an acknowledgements, and this is what makes TCP reliable, but also it makes it quite slow on networks where there's latency and packet loss. Another thing that TCP is also not very good at is that when you work on wireless or satellite links, where there's an inherent packet loss, you will notice that TCP is very slow because it considers the packet loss on the link as a problem as it's sending files too fast, so it tries to slow down, and that's what causes delays with TCP. Some of the stuff in TCP can be tuned. So the way it usually works is that you would have to, on Windows, open your registry and increase the TCP window size on the sender, and on the receiver you would have to increase the window size on the receiver. But that's to tune only to point, to one, from one transfer to another. If you're trying to, let's say, receive files from many different places around the world, well, you can only tune to TCP once on that box, so it kind of has to be tuned for everybody at the same time, and that doesn't make, it's not an ideal solution when you're kind of receiving files from all around the world with different network characteristics. Another thing, it does require, modification and changes, and you do know have to do what you're doing, because if you change your TCP settings to aggressively, you'll actually end up making everything much slower than it should be. So what we've done instead, we said TCP is great, it gives us retransmission and congestion control, but we're going to do this over UDP. When we send files over UDP, we can send them as fast as we want. We don't have to wait for acknowledgements. We can send everything as quickly as possible. So what we've done is we've built an algorithm which is actually patented at this point, and it's patented in the US. And our patent allows us to send files via UDP while listening to the feedback on the network and slow down or speed up as required, so we can allow other traffic through. And this is called the congestion control part of it. So we will send our UDP packets as quickly as we can. We will listen to the background network traffic and slow things down if needed to allow other traffic through. So our goal is to make other TCP networks slower, but not to kill it altogether. We're not affected by that latency, and we degrade linearly when it comes to packet loss. So once again, that's what I mentioned with TCP. We don't have to do the acknowledgement every single time. And because our protocol is fully multi-threaded, if you have multiple cores on your CPU, everything goes much faster. And this is where we can, on a fairly standard system, send at 10 gigabits with encryption, because we can leverage the multiple cores of the CPU. So one core could be encrypting, another core could be sending, another core could be checking for background traffic, and that's what creates the efficient algorithm that we can, on a fairly standard configuration, send files at 10 gigabits. So this is how kind of FileCatalyst UDP-based transfer works. So you have your source file and your destination file, but now what you see here is that we will number all our packets in such way that when they arrive at destination, the receiver will be able to rebuild the files quickly and efficiently, and will be able to identify what's this missing. So before, when you saw in this graphic, TCP was sending one little packet of data, we actually send as many as we can fit in the link. So your link is always busy. And on top of this, we don't wait for acknowledgements because all our packets are properly numbered. So when they arrive at the destination, it's very easy to rebuild the file and also to identify what's missing. At the end of a transfer of a block, we will do something called a retransmission request. And any packets that we lost on the way would be retransmitted for that block. And and so on and so forth. I mean, this is a very, very simplistic way of explaining this. There's a lot more complications to it, but I just want to give you conceptually what we do. So this is not smoke and mirrors. This is not compression. This is really a proper usage of acceleration of network to send bulk data. So let's talk a little bit about congestion. So once there's a transmission online, we will continuously listen to the feedback on that link and react very quickly to either speed up or slow down to allow other traffic through. On top of this, you have actually as well controls in our software that you can say how aggressively you want us to take over the bandwidth. So you could turn on something, say, go crazy and take off all the bandwidth because I need this data now. Or you can say, be more lenient with other TCP traffic and allow that TCP traffic to go through. We're also very good at ramping up and slowing down. So it doesn't take minutes to slow down. We will react fairly quickly. So this allows to very quickly to adapt to changing network conditions. And our goal is really with our protocol that from anything from 1 megabit up to a gigabit of speed, you don't really need to do any tuning. It just kind of works out of the box. Of course, if you want to start going into faster speeds like 2 gigabits, 3, 5, 10, now then we have to do a little bit of tuning to figure out exactly your disk speed and to kind of synchronize everything properly with reading and writing from the disk, because now we're at mercy of the hard drive reading and writing fast enough to do this operation. But up to a gigabit, there's really no tuning required. It just works. So how does latency affect speed? Well, here's an example of a graph that we've built for comparing FTP or any TCP-based protocol to FileCatalyst. So RTT is the round trip time. That's how long for a packet it takes to transfer from one end of the network to the other. And this is the throughput. So as you can see, as the RTT, which is counted in milliseconds, increases, FTP slows down quite quickly. So you can see already at, even if you have speeds, latency of, 10 milliseconds, you're already seeing quite a big drop off on TCP. Interestingly enough is that if your bandwidth is very low, if you're working with, residential line speeds like, DSL of like, 1 megabit, at 1 megabit, TCP is actually quite works well. So you will not see as much benefit on the slower speeds, but you will still get the reliability and, automated checksums and everything else we've built into our solution. But anything up below, I would say 10 megabits, TCP is actually will probably give you a fairly good results. Anything 10 megabits and up, then you're going to need something like FileCatalyst to optimize that speed. Another caveat here is that if you are considering to use this on your satellite network, so let's say you're using VSATs for, let's say, ship to shore file transfers, then satellite has right away a very big latency and packet loss built in. So even if your satellite is only, let's say, 500 kilobits or 256 kilobits, you will see a dramatic improvement with FileCatalyst because we're immune to that speed. So if you have very, very low speeds with satellites, that's one area that we can help you. But if you have a landline that is less than 5 megabits, we're probably not going to give you much speed improvement. Anything above 5 or 10 megabits, then the improvements will be quite large. And keep in mind that this is only just for the protocol itself. I'll be showing you a number of tools and management tools and transfer capabilities that you still be able to take advantage of even if you have low latency and low bandwidth. So how does this translate into real life? If you're transferring files around the world. So we took these metrics from real life scenarios that our customers have seen, and I'll give you some examples here. So if we take a 1 gigabit connection between Amsterdam and London, It's a fairly short haul. It's only like 350 kilometers, where RTT is about 50 milliseconds. A 10 gig file will take about an hour and a half. With FTP, we'll do it in a minute 23 seconds. Let's take a bigger distance. So New York City to Buenos Aires. Now we're going 8,000 kilometers. FTP will take 3 hours. We'll take a minute 23. So as you can see, FileCatalyst doesn't the speed doesn't change regardless how far the distance is and what's the RTT. You're always going to get full line speed of using FileCatalyst. While with FTP will slow down and considerably slow down. And then on 10 gigabits, of course, this is a huge improvement here because now we're talking about a very big pipe where sending acknowledgements on the TCP transfers will really bog down the transfers. And you can see our transfers are in seconds versus hours with TCP or any TCP or FTP based protocol. Another thing and interesting here, let's say if we said I had added here another row on top here that would have RTT of 0. So where would you get an RTT of 0? Well, first of all, you can't get RTT of 0 because there's always going to be some latency as soon as you're going computer to computer. But let's say you have 1 millisecond latency or 0.5 milliseconds latency. So really, really low, like local area transfers. FTP is going to probably get you somewhere around a minute 23, maybe 2 minutes to transfer the file. So you can see that FTP is quite fast if there's no latency. So once again, if you're looking to do local area file transfers, FileCatalyst might not be ideal. Now, if you go to the 10 gigabit transfers, because now we've optimized how we move data around, you might actually see an improvement even with very, very little latency. Even with 1 or 2 milliseconds latency, you might see a considerable improvement with FileCatalyst. But that would be only on the 10 gig side, because once again, even that 1 millisecond will cause things slow down. I mean, we've seen 10 gigabit links with 5 millisecond latency on the LAN transfers going at a gigabit, and we were able to get 10. So there is some scenarios where on local area network we can help. And can help quite a bit, but it has to be those really fast lines. You have to be working with like backbone of 10 gigabits. So as I mentioned, we have a number of products. Today we'll be only talking about FileCatalyst Direct, which I will get into a minute to a demo, but we also have a FileCatalyst Central product, which allows you to do administration and management of all your FileCatalyst nodes and deployments. It also allows you to do system-to-system transfers, meaning you're not transferring files exactly from your local machine to somewhere else, but you're transferring files now from one server to another. And it also gives you the ability to visualize your entire deployment. So you have a map, you can create yourself a map canvas, and then drop all your nodes on that map canvas, and you can see all the transfers at a glance. And then finally, Central also has the ability to send you alerts. So you can do SNMP traps or email alerts if something goes wrong. And FileCatalyst Workflow is our web-based portal for file transfer needs. So here we can address anything that really end users might want to do on the web. So would be, let's say, submission portal, where you're going to submit files to a central location. You could do email distribution. So you want to send large email attachments, but instead of sending it via email, you want to just send a link. That would be your workflow. And then also your ability to create online folders where you can kind of collaborate on files on the web. So that would be really your FileCatalyst workflow product. Direct has some limited capability, especially when it comes to sending email links, which I'll show in a minute. Workflow has that just a lot more features built around file sharing on the internet. So if some of the features are not possible in Direct, then sometimes workflow is required. So let's just talk a bit about Direct and how it follows. So it is a client-server type of architecture. Uh, at one point, we'll give you a FileCatalyst server application. It's going to be right here. And the server application is going to be connected to your storage. It could be a network attached storage where all your files reside. And the FileCatalyst server will have users and will connect those users to specific folders on your storage. Or it could also connect to storage on the cloud. And once it's connected on the cloud, then you can move data, of course, to the cloud instead of to your local storage. And of course, you don't even need a storage. You could just use a local hard drive. In case of the simpler deployments, we can do that as well. So then you're going to have and this is once again a very simplistic deployment, but you have your internet connectivity or your wide area network. And on the other end, you're going to have a number of client applications that can both push data or files to the server or pull data from the server. And we have 5 because there are different use cases. So let's go quickly through them. Hot folder is our automation client. So this is our automation and synchronization client. So imagine hot folder can wake up, let's say at midnight, check for new files over here, and then automatically upload them to the server and put them in the right storage here. And vice versa. It could be monitoring files over here. It could then locate new files and download files to a specific location on the hot folder. Desktop applications, this is more like a FileZilla type of deployment. So if you ever used a FTP client where you have the 2 panes and you want to transfer files between your local computer and the server, you just connect. You will have a local file listing and a remote, and then you just upload and download files between them. Web browser, I'll be touching the top 3 really in my demo in a minute, but web browser allows you to connect to the web and transfer your files directly from the web browser. So you'll be prompted to install a plugin, which I'll cover in a minute, and then once the plugin is installed, you can either upload, download, or do the 2-way operations where you can upload and download in the same screen. Mobile, if you go to Google Play or iTunes, look up FileCatalyst, you'll find our app. You can download it, install it, point it to your server, and then you can upload content to the server. And SDK, that's quite a big. We have a big list of different APIs that we can provide you. So we have a Java, a C++, a command line, a .NET, a REST, a SOAP. Anyways, a number of different ways you can utilize this network. We also have a number of REST services that allow you to do server-to-server transfers if you're connecting to Central. And Central then kind of organizes which server and which client is sending files, but you can do that with server-to-server transfers using Central. So that's really, so today we're going to be talking about the server here. We're going to be talking about the hot folder and the browser. And in essence, we're going to be touching the desktop as well, because I'm going to show you the two-way portions of the hot folder and the browser of the transfer agent. So let's start with our server application. So now we'll be talking about, just to go back here, we're going to be talking about this box in the deployment, where you will have the ability to, this is where you create the users and stuff. So let me just bring it up here. So FileCatalyst Server is really a software application. We're all software based. There's no hardware. We don't need to ship you boxes. It's all just software. So the server application allows you to define users. You can create users and point them to a specific path on your system where their home directory will be. So once this user logs in with one of the FileCatalyst clients, they will be able to see the files in this directory. You can control what the user can do. For example, you can set up the permissions, whether they can upload, download, list, and so forth. You can also set up quotas on bandwidth. So one side effect of using UDP is that we can be very precise at the speeds we want to send. So you can, impose specific bandwidth limits or priority on bandwidth for users. This is something that TCP doesn't really let you do easily. You cannot, speed up or slow down TCP without a bit more background work. So a user will be defined here. As I mentioned, users can have also their SFTP public keys, and also users can be defined from LDAP or Active Directory. So if I go to authentication here, I can specify an LDAP server or Active Directory, and then all my users come in are automatically created and provisioned based on the user defaults here. So you can create, what permissions and bandwidth and quota and all that stuff can be created automatically. Another thing with users, what we have something called virtual files and folders. So in this case here, I can create a number of folders. They could be pointing to local drive. They could be pointing to a cloud storage. They could be pointing to a network storage. And then I can assign these virtual folders to specific groups, and then those groups can be assigned to users, which then the user will see another folder on their list. So when let's say when the user logs into this directory, there might be a folder called match1 if this specific folder is assigned. So I'm going to go just into here, and I'm going to add this user read and write. There we go. Let me just do that so we'll see this match1 folder. So you can see you can bypass the group functionality and just assign virtual folders to or files per user, or you can assign them to a group and then assign groups to user for larger deployments where you have maybe 100 users and you don't want to be sitting there clicking which folder this user is allowed to see. FileCatalyst servers also an FTP server, an SFTP server, and an FTPS server. So when you're configuring FileCatalyst, it can be completely backwards compatible with your legacy applications. So if you have some applications that need to drop stuff using FTP, you can just enable FileCatalyst on port 21, and then FileCatalyst will look like an FTP server for the legacy stuff. Of course, there will be no acceleration at that point, but at least you'll be able to integrate it easily into your existing environment. And same thing with SFTP or FTPS. So this is the important part here on the FileCatalyst servers, that you have ports, and then there's your data port range. So this is keep in mind that these are transient ports, so they only open during the transfer and then they are shut down. But these are the ports that you would need to have for TCP and UDP opened on your firewall, so data transfer can go. And usually it works for every transfer. There's one port open. So if you open only a small range of, let's say, 20 ports, then you'd be only able to really do 20 concurrent transfers at the same time. The more ports you open, the more transfers you can handle through those ports. We do have a reverse proxy available for those users that cannot open ports on a firewall. And then what happens is that the reverse proxy would be living in the DMZ, where it has where you can open the ports, the necessary ports, and then the communication between the server, FileCatalyst server, and the reverse proxy would be going over a single outgoing port. So this makes things a lot simpler for the more advanced deployments where you need this. We also have something called a forward proxy, and that would be for the client side. So if the client is behind a firewall, they cannot connect directly to the FileCatalyst server. A forward proxy would be sitting between the client and the server, and then they would be able to communicate via that way. Security, we have SSL and AES, up to 256-bit encryption. This is for securing both your network and your data. Usually for very high-speed transfers, if you want to go, let's say, gigabit or more, we recommend to disable this because it is a quite big CPU-intensive process. And while you still have your command socket encrypted. So even if someone can get to this port and read the UDP data coming through without the SSL and command socket, it's very hard to figure out what to do with it. So that gives usually satisfactory amount of security to our users, and doesn't require to put up a very big hardware requirement on the transfers. Uh, so uh, there's a system monitor here. This is where you can be able to visualize all your file transfers as they're coming in. Right now I have nothing going on, but I'll start a transfer and you'll see in a minute something appearing here. Link, I'll be showing you the link as well, where you can send files to an email address without needing to attach the file into the email. And central here, this is, as I mentioned, this is our central management and remote administration tool. You can connect all your nodes, server, hot folder, transfer agent to central, and then remotely manage and control everything. I'm not going to be getting into this demo, but at least you'll have an idea that this exists. We have some limited reporting built into FileCatalyst server. We'll create something called a CSV file, and then you can run reports based on user bandwidth and dates. This is all just creates really CSV files, which you can then import into Excel or whatever and create other more advanced reports. If you want to have more verbose logging and reporting, then you would require central, because every single transfer is sent to central, and central tabulates it all and shows it to you in a much more flexible format. And so if you're looking for advanced reporting features, consider central in your deployment. But if you're just okay with basic reporting, then this is built into the FileCatalyst server. So that's the server side. Now I'm going to be talking about the client application. So I'm going to start with the hot folder. So the hot folder is our automation client. So remember that hot folder will be connecting to the server and doing the transfers. So let's go back here to our hot folder application. And so what do we have here? Well, first of all, hot folder can support multiple FileCatalyst servers. And keep in mind that sometimes they don't have to be different servers. They could be just pointing to the same FileCatalyst server, but just as a different username and password, because you want to access through this other username and password a different area of your storage or your NAS or your drives. Also keep in mind that there could be multiple hot folders created, because as you're creating different sites and hot folders, you might want to schedule different tasks. So dependingly what you're trying to do, whether an upload or a download, you can create multiple tasks. So hot folder will be really the space where you're either uploading from or downloading to the files. Schedule, this is really the brain of the operation for hot folder. So let me show you here a property of this one. So first of all, you specify the name, whether it's an upload or a download, and you can set up your schedule. So our scheduler is very flexible. It can go from every minute, every second, every Tuesday at midnight. You can create quite a flexible schedule of your transfers. And then your connection, this would be your information on the as I mentioned, we have the congestion control protocol. So we have something called RTT based and loss based. Dependingly, if you're sending files on satellite or wireless communication, you can change the strategy. And then you have aggression. So this will tell the hot folder how quickly you want it to take over free bandwidth, or maybe you want to go slower. So if you set something to like 2, it will play more like TCP. If you set it to 10, it will play more like a UDP application. And you can change those settings per task. Verify file integrity. So this is where you can, after the transfer, we'll do a full MD5 checksum of the file, and excuse me, and then only once the MD5 passes, then we will deem the file is correct. We can transfer with something with a temporary file name. So while we're transferring a file, this will have a prefix, let's say .fc, and then you know that this file is still being worked on. So other applications that rely on this file will not pick up an uncompleted file. We can keep file modifications timestamps, so you can keep your cdate, mdate, user permission, at least on Linux. We don't do it on Windows, but on Linux we will keep everything. On Windows, I think we're limited to only maybe mdate and cdate, if I'm not mistaken. Multi-client, this is what allows you to transfer multiple files at once. This is very useful, especially if you're not using UDP. If you're not using UDP, let's say you're using a TCP protocol or using our HTTP fallback, then you can send multiple files at once, which gives you acceleration. And this is also very useful for growing files. So let's say a file that is still being written to the disk and you want to transfer it, you enable this, and then what it means is that once hot folder reaches a file that is growing, it's not going to get stuck. The other clients will continue transferring other things in a directory, while that client is going to be busy kind of chasing the end of the file that is still growing. Data minimization, as I mentioned, we're not really about compression. We do have it built in. We have ability to also to do something called single archive transfers for a lot of small files. So sometimes this is useful. So when you're doing large data transfers, the big thing is you need to know your speed. You need to know your data set. Are you doing a lot of small files or rather big files? You need to know how big is your directory structure. So there's a few things you kind of need to know with the hot folder if you're doing very, very large data sets. And then, you know, you can configure these tasks, maybe one for smaller files, one for larger files. What smaller files could have the single archive enabled. All these options are available for you. Incremental is an option here that allows us to transfer deltas. So imagine we transfer version 1 of a file. 2 days later, there's a new version of the file. Then we'll compute the delta and transfer only the delta. This is useful for places where the bandwidth is maybe slow, because usually on faster bandwidth, to be honest, it's better to retransfer the whole file than trying to recompute the delta, because computing of delta does take time. So that's something you'll have to figure out once you're transferring, whether it's I have a lot of bandwidth, so I'm going to just retransmit everything and not wait, or I have very poor bandwidth and then I need to recalculate. So definitely a bit of, you know, testing for these type of applications would be useful. Dynamic file sets, so this is what I'm calling growing files. This is very useful in media and entertainment space, like in movie and TV production. It is useful sometimes for PST files on Outlook, like backing up Outlook. While a PST file is being created, we can transfer it. But it's more limited in other spaces, the growing file side of things. But in media and entertainment, this is very important for two things. While the file is growing from, let's say, a camera or an encoder, we can transfer it right away. And at the same time, we can also maintain headers. So for example, if MXF header changes as the file grows, we will maintain that header. This allows us to make that MXF file editable on the destination before it completes. And it's useful for this. We also have something called a reverse reverse growing files, so actually you can skip all growing files and wait for them to finish transfer before we touch them. But these are some of the options. There's quite a few things here we've done. We've done a lot of sporting events based on this feature. We've done Super Bowl, we've done Olympics, Winter and Summer Olympics. We've done French Open and World Cup, I think Soccer World Cup, and it all has to do with that. I feature the idea of sending growing files and being able to edit the file as it's being still transferred from the venue back in the studio. Um, so that's a bit of a side note, but I'll continue here for those that are not in media specific and media specific branch. So if we look at the file sets, so file set, it allows you to say, transfer smallest files first, or perhaps you want to create two tasks, one for small files, one for large files. You also here have your synchronization options. So if you want to continue, if you want to synchronize um, folders, you create the synchronization is called a master slave type of synchronization. So we cannot do a master master. But if you, however, want to maintain a master folder and then push it down to a branch, you can do this. So every file that is deleted at destination, it's going to also delete the file at source and send also remote file information. So if someone renames a file, we will capture that and rename the file instead of retransferring it. Transfer cache is also important for those that are sending file folders that they don't want to delete after transfer. So transfer cache will remember what was transferred and will not retransfer it again. So this is important. By default, this is disabled. You have to enable it for those that are transferring, folder structures that you want to leave on the disk. And this brings me to my PostTask. What to do if transfers is complete. Do you want to delete the files, leave them there, rename? Once again, the file transfer cache is useful if you do nothing. Because otherwise, if you do nothing and you don't have cache, that folder will be retransferred every single time. And here for my demo, that's what I do because I want to make sure that I show you a transfer going. So that's pretty much it. Bandwidth schedule, you can say in the hot folder, Monday 9 a.m. to 6 p.m. go slower, Monday through Friday, and then weekends and evenings go faster. You can specify all these information in your hot folder to make things go faster or slower depending on your time of day. Administration, so you can again remotely manage the hot folder. If it's installed on headless Linux, for example, you'll need that. And again, we have some reporting built in. I think this reporting actually does require a license key, which I don't have here. And if you want the most reporting from hot folder, then of course connecting it to Central, and Central will gather all this information and give you a nice report. Once again, this is really not a demo of Central. It would require another hour, which I don't have today, and you probably don't want to sit on this demo today for another hour. But this is something that you can as well do with hot folder. So let's just do a transfer here so I can show you what's happening. So let's say I'm going to just go here, slow this down a little bit to, let's say, this speed, and I'm going to execute this task. And now you can see the transfer is going. You can see I'm transferring 3 files at a time because that's what I've configured. And you can see here my speed and how fast I'm going with the transfer. So if I go into my server now, so this is on a hot folder, you can see my clients, which client is doing which file. I can see the graph per file, and then I can see the logs as well for all the transfers. Now if I go into my server, and I go to System Monitor, you can see here the speed, and here are the 3 clients concurrently transferring files at the speed of 45 megabits or so. So see, it's divided kind of evenly. The bandwidth is divided at 14 megabits each, and 14 and change. So this gives you the 45 megabits, and I have the monitoring here. I can see what's going on. So at any given time, I can click on any of this session status here and bring up the information for this client and what it's doing and how many files. So you can see from the server I have full visibility of what's transferring and when. And this is very useful for businesses that receive a lot of files from many different places. So you can control your transfers, you can see patterns, you can speed things down or slow things down as needed. So you can, based on your operational requirements. So this is one transfer. So now let's just I'm gonna go back to the server here, and I'm gonna go into my bandwidth, and now I'm gonna just give it a nudge here so it goes a little faster. So let's say I'm gonna go to 100 megabits, and so now I've sped up my transfers, and this probably will take, I think we just finished transferring everything, so I'm gonna have to restart the transfer. So hold on, just open my hot folder, scheduler, and execute this task again. And now I'm gonna have much faster speed. You can see again 3 files are going all at once, and you have your current rate. I can see what the clients are doing, and now the clients are going, well, they'll be going a bit faster. It's probably just the files are a bit smaller, so they never can really speed up to the full bandwidth. But you can see this system kind of working with multiple files, sending and receiving. You always know how much time you have left to transfer, and you know exactly what's being worked on, and from both from the server and the client side. So that's the demo of hot folder and the server. Oh yes, I wanted to talk about the basic functionality of the desktop transfers. So one thing that hot folder can do, if you don't wish to do automated tasks, you could just create a whole bunch of sites in hot folder, and then once you have those sites, you can click on the connect button here, and this opens sort of an interface similar to FileZilla, where you can move files. So you can see here, I can now connect, and I can move files easily just by selecting and manually uploading the files. So here's what I'm doing is I'm creating this is like a FileZilla type of deployment. So you can see here I'm transferring files, and now they are all kind of going on their own, very similar interface to FileZilla. This is manual, it's easy to do, and it's built into hot folder. So this is the part of the hot folder that's kind of easier to use, because there's no automation required, no task setup, and so on. Okay, now let's go back to the next step. I wanted to show you what would be the link. So I'm just gonna make sure that my link is enabled, and now I'm in the web browser world. So everything here I'm doing is via the web. So let me show you a few use cases. This is all built into Direct, by the way. There's a lot more advanced type of web-based workflows you can do with workflow, but this is kind of the baseline that we ship with Direct, so you can actually see what you can get just from the basic operation of web-based transfers. So I'll show you the email link. So you can see that this is asking me to launch transfer agent, which I already had installed, and this starts my transfer agent. So what it did here, it started a little application. This is the transfer agent application that talks to the web browser locally and transfers files via the web. So here I can now enter information of the files I want to send. So I'm going to just send one file, demo, and some demo. And what I can do here is I can select files sitting locally on my drive. So I don't know, I can go here and select a few files. And I also can go to the remote server and select files this way as well. So these files will not require these files will not require an upload, because they are already sitting on a server. So you can see here I have my local file system and remote files, and I can select what I need to send. Once I upload this, I can just click on send, and this emails this this link to the receiver. So now I'm going to close this up. This is exactly I'm just going to close this up, and now I'm going to pretend I'm the recipient of these files. So here's my email client. I just downloaded Thunderbird for demo, but it works, you know, with anything, Gmail, Outlook, it doesn't matter what you're using. And now here's my link demo, and I just have to click on this link, and this is what the receiver would see. So this is a live demo, keep in mind. So sometimes could be a glitch sometimes. And the recipient here can download the files. And what's going on? There we go. So as you can see here, I can now download the files that I picked up, and I can just add them to my queue and download the selected files. And this will start the transfer as a recipient. The files will automatically go into the downloads folder, because that's how transfer agent is configured. So once the transfer is complete, I have here open download location, which opens my browser into the downloads folder, and here are my files. So this is the link capability. I can show you also the upload capability of transfer agent. So here I'm logging in to the FileCatalyst server as a user, and I'm uploading files to my home directory. So I can just go here, pick any file I want. So I say this one, and start uploading these files. So this will not generate this can also generate an email notification that something has been uploaded, but doesn't generate a link. This is more just for uploading. And by the way, all this stuff here can be integrated into a third-party application. We provide a full JavaScript toolkit to do all of this through the web. So if you have a web application that requires fast accelerated web-based file transfer, will provide you an API that you can do all of this through the web. So here I sent some files, and then finally I wanted to show the download. The download looks similar to upload, but now here I'm seeing the files that are sitting on a server, and I can download them if I want. So here there's no link here. It's just ability to download whatever is in my folder. So this is all this stuff is built into the server. You get all of this as part of your direct offering. The hot folder, the connect and hot folder, the server. There's the link capability, the upload and download capability, as well as you can get the API for doing this in your own application. Last but not least, continuing talking about the browser stuff. Once the transfer agent is installed, transfer agent is more than just a plugin for the web browser. Transfer agent also comes with its own ability to transfer files. So as it runs in the system tray, all I have to do is just right click on it, and I can go to something called Transfer Agent Express. And this opens up, I can create as many, this opens up an interface similar to FileZilla, where I can now connect to any FileCatalyst server, and I can now start uploading and downloading files. So I can here connect to C drive and select the file and start uploading it. So you can see here, this is more of a this and the hot folder connect are practically the same. It's the same feature. It's just one is on the web and one is built into hot folder. The reason we have this here is that this is your other ability to do your desktop FileZilla connection. So when we go back here, this desktop app is really either hot folder or this connect method in transfer agent. So that concludes my demo. I will be getting shortly into questions. So if you have any questions, please think of them now. I just have a couple more slides. So If you're looking at UDP accelerated file transfers, here are some of the considerations. This is what you should be thinking of if you're thinking of deploying or acquiring a license to acceleration. Make sure you find something that plays fair with other network. So make sure that your TCP network is able to go through and doesn't slow down. So it has a congestion control built in and can adapt to the speeds. I can tell you on them there's some open source projects that claim to do UDP, and they do UDP, but they don't have the adaptive rate controller. So that means you only can start them at one speed, and they will go at that speed forever. They will not speed up or slow down. Other commercial products usually do. Make sure you have something called guaranteed delivery. So after a transfer, we'll do some. The application should be doing an automated checksum. So do an MD5 checksum of the files to make sure there's no errors and corruption on your files. Most TCP protocols like FTP, SCP will not do that, and that's why sometimes you end up with errors because you never kept that guaranteed delivery option. Make sure you look at, if you're looking at faster speeds at a gigabit or higher, make sure that the solution you're considering can go that fast. Some of the other commercial products especially can maybe only do 2 gigabits or maybe 4. If you're looking at doing 5 or more gigabits, make sure you do some research and you pick the product that fits the bill. As I mentioned, we can do 10 gigabits with a bit of tuning, but it's usually not a problem for us. We have actually even some deployments recently at 15 gigabits, which is also possible. But anyways, that's something that you'll need to consider if you want to be doing these very, very fast speeds of transfer. Make sure you have some kind of an optimization algorithm for small files. So it takes a very long time to open a socket, transfer one file, close the socket. If the files are very small, it will take you longer to open sockets than transferring files. Once again, this is something unique to FileCatalyst, where we will transfer what we call small file streaming, where we transfer multiple small files in one socket, so you're not wasting time waiting for the small files. Make sure that the solution, if you need to transfer very, very large data sets, perhaps 2 or 3 million files or even more, make sure you pick a solution that can handle that. And once again, not every file transfer software package out there can do this. Make sure you have some kind of security, reliability, automatic resuming built in. So if there is a drop on the network, the application will automatically resume from the point it last was able to do it. So like checkpoint restarting. Make sure there is some reverse and forward proxy support. Once again, now usually the open source projects don't do that. Commercial ones will have some reverse and forward proxy support, but make sure it works, and also verify the speed of the reverse and forward proxy. For example, our reverse proxy can maybe get you about a gigabit. If you want to go faster than a gigabit, we're working on optimizing it, but that's not something we do yet. And verify that reverse forward proxy is as efficient as what you expect it to do. Make sure you have automation tools, SDK, and a central management, as I mentioned. Make sure that you have something that transfers multiple files at once. As I said, if the solution you're using right now gets stuck on a growing file, well, then nothing else is going to get transferred in the directory until that file stops growing. While with our solution, if you transfer multiple files at once, well, first of all, you're not going to get stuck on a growing file, and second of all, if you're using HTTP fallback, which we have built in, and TCP fallback, then you can get acceleration by doing multiple streams at once. How are the growing files handled? Can it do growing files? Can it resync headers every time it grows? What about maintaining Linux file attributes? Can it maintain user permissions? Can it maintain mdate, cdate? Can it maintain UID, GID configuration? So these are all the things you should consider when you're looking at file transfer tools. And finally, if you're looking into moving data into the cloud, like S3, Azure, OpenStack, make sure the solution does support that. And what are the maximum capable speeds? Because you might say, I want to transfer at 5 gigabits to S3. Well, that's not going to happen without an acceleration tool. And that's something we provide, and not everybody else in this market provides this. So we've been doing this for over 10 years. I mean, we have a lot of clients. We've amassed a lot of clients in this space. This is a small list of some of our esteemed clients we work with on a daily basis to move their data. And it's been, we definitely have a lot of knowledge when it comes to data movement and acceleration. And I think it shows with the number of different clients that we work with, both in media, uh, oil and gas, health and genomics, enterprise IT. Um, Anyways, there's a number of verticals where we work, and we provide file transfer services. So as I mentioned, um, at this point, if you have any questions, I asked you if you wanted to think of any questions. Now it's a good time. So I'm just gonna stop my recording. So thank you for those that have been watching the recorded session. I'm just gonna stop my recording, and I'm gonna get into questions right after.